Hello, welcome to part 4 video class on Is Matter Around a Sphere. In this video, I am going to discuss with you different separation techniques. How we can separate the different components in a mixture. In your 6th standard and 7th standard class, you studied about different separation techniques. For example, sieving, filtration, centrifugation, sedimentation, all those things you studied in your lower classes. In this video class, I am going to discuss with you some of the separation techniques. First one is evaporation, second one is centrifugation, third one is with the help of separating funnel, and fourth one is by the process of sublimation. So what are these techniques? In which case you will be using these techniques? That is the main thing I am going to discuss in this video class. So first one is evaporation. What do you mean evaporation? In which case you will be using the process of evaporation? See, for example, if it is a homogeneous solution, that means both the solute and solvent is of same phase, or we will not be able to distinguish between them easily, or homogeneous mixtures. So at that time, and what is the principle behind evaporation? One of the substances is more volatile than the other. That is the principle behind evaporation. One of the substances is more volatile. What will be more volatile? They will get vaporized easily than the other. So in this case, we will be using the process of separation. I will give one simple example of evaporation. That is, we will be able to get the salt from seawater by the process of evaporation. So what we are doing there? The seabed is made, and when sunlight falls on it, the water, which is more volatile than the salt, it will evaporate, and what will be remaining there? The salt will be remaining there. So that is the process of evaporation. So the principle behind evaporation is one of the components will be more volatile than the other. So salt can be separated from seawater by the process of evaporation because water is more volatile. Then another example for evaporation is, which is given in your textbook, is this process of evaporation for the different dye or color in the ink. See, for example, we know ink. Ink is a mixture of two components. One is the coloring agent called the dye, and the other one is solvent, maybe water. Here they are having difference in their volatility. That means one of them is more volatile than the other. Here the solvent is more volatile than the dye or the color. So here the process of evaporation can be used. We cannot heat ink directly. So what we are doing is, we are taking a beaker with water in it, and we are burning this, or we are heating this beaker. When we are heating this means, what happens? The water will evaporate, and we are keeping a watch glass over it, and 1 or 2 drops of ink will be poured in it. So we are not directly heating the ink, we are indirectly heating the ink. So what will happen now? When the heat reaches that ink, more volatile solvent will get disappear or evaporate. So what will remain there? The dye or that coloring agent, which is less volatile, will remain there. That is the principle behind evaporation. So what is evaporation? It is used for separating those components which are having difference in the volatility. The more volatile component will evaporate faster, and the less volatile compound will remain there. In the mixture of salt and salt water or seawater, the salt will remain there and water will evaporate. In the case of ink, the solvent will evaporate or get volatile, or they will be separated easily, and the dye will remain there. That is the principle behind evaporation. It is done for ink. In the case of ink, it is done indirectly. We are boiling the water, and the heat from the boiled water is separating the components in ink. That is evaporation. Next one is centrifugation. Centrifugation is usually applied for colloidal solutions. You know some examples of colloidal solution. For example, this milk, butter, all these things are starch. They are all colloidal solutions. For separating the different components in colloidal solution, we are using the process of centrifugation. See, I told you, in the process of filtration is not applicable for colloids. Why? Because in the case of colloids, the particles are comparatively of larger size than the true solution. So the process of filtration cannot be used there. There we are using the process of centrifugation. So the process of centrifugation is nothing but rotating this. This is a rotatable machine. It's called the centrifuging machine. What we are doing is, with the help of this handle, we are rotating it, and we will be pouring the colloidal solution in it. when we are rotating it, what will happen now? Because of that high speed, the heavier particles will settle down and the lighter particles will be seen at the top. That is the principle behind the centrifugation, rotating at high speed so that those particles which are having weight, they will be settled down, and those particles which are light will be seen floating. So we will be getting the two different layers and we can separate the thing. So this process you may be seeing in the other way, the process of centrifugation in your home, that is mother. They will be taking this butter from milk. That what they will be doing is this, they will be taking this curd or buttermilk and they will be churning it. Churning is the process of centrifugation. What is churning? The lighter particle or the butter or that fatty portion will be seen floating, and the heavier one, that is the water, will be seen at the bottom. So the butter will be seen floating after the process of centrifugation or churning. So what will happen now? The butter can be separated from the milk. That is the process of centrifugation. It is applicable for other type of colloids also. For example, in the case of blood I told you it's a colloidal solution. So blood and this urine, for testing the different components, for separating the different components in blood and urine, that is for the blood and urine test, we are using the principle of centrifugation. So it is applicable for colloidal solutions where the size of the particle is comparatively larger, which cannot be separated by the process of filtration or with the help of a filter paper. So we are rotating it at high speed, and so because of the gravity, they will be separating. Because of the gravitational force exerted, they will be separating. That is the principle behind centrifugation. Churning of milk. Similarly, one more example of this centrifugation is the spinner in our washing machine. For drying the clothes, we will be putting the bed clothes, and you might be seeing the spinner rotating very fastly, and the spinner is having a lot of holes in it. So what will happen now? The cloth as well as the water will be moving at very high speed, and the water cannot move along with that of the cloth, and so what will happen? The water will fall down. That means through the pores of that spinner, the water will go out. What will be remaining? The clothes will be remained without water, they get dried. That is the principle behind this process of centrifugation. Also, we are rotating at high speed. So what happened now? The water cannot go through that. They will be falling down, and through the holes of the spinner, they go out. What will remain there? The cloth will remain there dried. So that is the process of centrifugation. So centrifugation is used for separating the different components of colloidal solution. For separating the curd from buttermilk, we are using the principle of centrifugation. For separating the different components in blood and urine, we are using the principle of centrifugation. And also for separating the water from clothes in spinner in the washing machine, we are using the principle of centrifugation. So centrifugation is rotating the thing in a larger speed so that by the force of gravity, different components in the mixture is separating. That is the principle behind centrifugation. And this is a centrifuging machine which can be rotated manually. Either machine machine work manual centrifuging machine. Next is the process of separation with the help of separating funnel. Here, the technique is applicable for immiscible liquid. What do you mean immiscible liquid? See, we can see a clear boundary between the two solutions. Such solutions are called immiscible solutions. For example, if you are taking oil and water, whatever may be the mixing we are doing, if you are keeping it for rest some time, you can see two different layers. Oil layer will be at the top and the water layer will be at the bottom. So that the boundary is clearly visible. Such solutions or mixtures are called immiscible solutions. So for this immiscible solution, we are using the technique of separating funnel. So this is a separating funnel. So separating funnel is having a, see, listen here, it's having a nozzle here and it's having a cap here. So we are taking this immiscible solution. For example, oil water mixture, we are taking it, we are pouring it here. We are allowing, there will be a stand here, there will be a stand for keeping the separating funnel. We are allowing it and for undisturbed for a few seconds. So what will happen now? Because of the gravitational force, they will form two different layers. That layer can be visible for us, or they are immiscible solution. So we can see the oil layer here and the water layer here. Now what we have to do is, you should have to open this lid, should have to open the nozzle, should have to keep a beaker here. slowly we should have to open the nozzle. What will happen? This water will be coming down through the nozzle, and through this small portion the water will be collected here. And what happened now? This oil layer will come here. When all the water gets removed, the oil layer will come here. At that time, should have to close the nozzle. Now, we should have to take the beaker. Now, you got the water separated. Again, you should have to take a new beaker and keep it here. So, what will happen now? Open the nozzle. What will be coming? The oil will be coming. Thus, by looking into the boundary between the true solution, between the oil and the true solution, or between the oil and the water, we will be able to separate the component. That is the principle behind separating funnel. So, this is nothing but another form of sedimentation and centrifugation. What is sedimentation? Allowing it to settle down for some time, so that two different separate layers will be formed. What is this decantation? Separating the component. The same method only, but here we are using a special technique called separating funnel. So, when we are opening the nozzle, what will happen now? First, the liquid, that is the water, will be coming down, and then we are closing the nozzle, and after that what will be coming? The oil will be coming. Thus, the two subcomponents can be separated by taking two different beakers at the bottom of this nozzle. So, that is the principle behind the separation by separating funnel. This can be used in industrial way also. For example, in metallurgy, that is for the separation of this iron from its impurity. That is in the preparation of iron. No, that process is called this. It is done in this blast furnace. It's a special type of furnace, blast furnace. It is having different zones. All these things you will be studying in detail in your 12th standard class in the process of metallurgy. So what will happen now? This blast furnace is a huge furnace, and at the bottom, what will happen now? This impurity will be coming, and this impurity is called the slag, and this impurity, that is will be formed, will be iron silicate. The impurity will be iron silicate, and under this will be the iron coming, that is the molten iron coming. So, just so the impurity will be here, and that is in the process after this process of separation of the iron, the impurity or iron silicate impurity, FeSiO the silicate impurity will be there, and the iron will be here. Pure iron will be here. Or we can say the impurity is seen floating over the molten iron. So they will be having a clear demarcation or the clear separation between the impurity and the original iron. We have to separate this. Here also we are using the process of this separating funnel. We are allowing it to remain there for some time. So what will happen now? The impurity will be seen floating over the iron. Iron weight to molten iron. What about this iron silicate? It is the slag or the impurity which is very thin, or not very thin, it's very light. So what will happen now? By the process of separation, we are separating the two components. First, we will be allowing the slag or the lighter portion of the impurity to flow through this way, and the heavier portion, that is the iron which we need, will be allowed to pass through the other point. So, by the process of separating funnel, or by the process of this technique, this technique is same as that we used in the separating funnel. We are separating the lighter particles through one area and the heavier particle through the other area. So it is applicable for the separation of impurity from the metal, for example in the extraction of iron. That is about the separating funnel. But in the condition, they should have difference in their density. If they are having very high difference in density, they can be easily visible. They will be immiscible, or we can say they are two immiscible liquids. There, the process of separating funnel is used, or the process of separation of sedimentation and decantation is used. Next is the fourth one, that is sublimation. It is applicable for sublimable substance. I told you about some sublimable substance. What is the specialty of it? They will be getting converted directly from the solid state to the gaseous state. No intermediate liquid state will be there. For example, in the last class I told you about some sublimable substances: anthracene, naphthalene, the odonyl we are saying, then ammonium chloride, camphor. All these things are sublimable substances. So if there is a sublimable substance with us along with the mixture, which method we can use? For example, if we are having a mixture of salt and ammonium chloride. If you are having a mixture of salt and ammonium chloride, one of the substance here is sublimable, which is that ammonium chloride. So we are taking a crucible, and in this we are keeping this mixture. Which are the components in it? Salt and ammonium chloride. I want to separate these two. So I am putting one, or I am keeping one inverted funnel over this mixture, and the nozzle of this funnel is closed with a cotton. Wet cotton. Wet cotton is vapors will be coming, and we are heating this. We are taking a crucible, or we are taking a watch glass. In that we are keeping the mixture of ammonium chloride and sodium chloride or salt. We are covering it with an inverted funnel. The nozzle of the funnel is closed with a wet cotton, and we are heating it. When we are heating it, what will happen? Naturally, sodium chloride heat it's having high melting point. Melt vaporize. What about the other one? Ammonium chloride is highly sublimable. What will happen? It gets directly converted to its gaseous state. That means they will be moving up. Ammonium chloride will be moving up. Can go out? No, it's covered by the nozzle is covered by a wet cotton. Why we are using wet cotton means that hot ammonium chloride, when they reach this wet portion, they get condensed. So what will happen now? They come back, they condense, and they get fixed on the surface of the funnel. So what happens now? The funnel will be covered by ammonium chloride. You have to continuously heat it so that no vapors are formed. No vapors are formed means no ammonium chloride is still there in the mixture. Now what will be remaining there in the mixture? There will be only sodium chloride. Where will be this ammonium chloride? All this ammonium chloride will be deposited on the sides of the inverted funnel. So by scratching the funnel, we will be getting ammonium chloride separated. And from the watch glass or from the crucible, you will get sodium chloride. So the process of sublimation is used there. So sublimation process can be used only for those components in which one of the mixture will be a sublimable substance. Here ammonium chloride is a sublimable substance, so we can use this technique. So the different separation techniques in crystallization, sieving, filtration, hand picking, condition. If the impurity is quite visible and there are only few impurity which we can take with our hand, then we will be using the principle of hand picking. So there are different techniques depending upon the need, depending upon the technique which we are accepting, we can use that different technique. I think the video is useful for you. Thank you.